Today's lesson is on isotopes. It's the first part of a three-part series on nuclear chemistry. Today we're going to define isotopes and take a look how they're a lot like sheep, oddly enough. Now, since I teach agricultural sciences, and this is one of our Ag Core classes, I thought I'd use an analogy that most of you are familiar with. And since most of you show livestock or have been around livestock and been in a vet science class or an animal science class, I want to use sheep as an example of what isotopes are. Because if we take a look at sheep breeds, here are three very popular or common breeds that we see on the show circuit. We have Dorsets, we have Suffolk, and we have Hampshire Sheep. Sheep are all different kinds or varieties of sheep, just kind of like chemicals. Isotopes basically are different variations of a particular element. So if you have an oxygen, there are different types or kinds of oxygen. Just like a sheep, sheep all have wool. Sheep are ruminant digestive system. They tend to have herding instincts, and really, when we're talking about sheep, they have some very basic kinds of behaviors as well as characteristics. For instance, if we take a look at Dorsets are definitely a sheep, but they tend to be, of course, all white wool, white faces. They twin on a pretty regular basis, so they have an average lamb crop of 180%. That means they twin quite frequently. They are used for wool as well as meat, but nobody would argue that they're a goat or a horse. They're sheep. They have wool, and they herd, and of course they have that ruminant digestive system. They're all sheep. Same with Suffolk. If you take a look at a Suffolk, you'll notice right away it's different than a Dorset because it has basically a black face right here. It has all hair on its head. It has hair on its legs, but it has wool everywhere else. These particular sheep grow extremely fast. They're really tall, and they tend to produce a lot of meat. So they would basically, again, be a sheep, but they use for meat breeds of sheep, and they have about 160% lamb crop. So they're not quite as prolific as Dorsets, but still, you can't argue that they're not sheep because they are. Then we have Hampshire sheep. They have wool on their face, and if you take a look here, a nice little wool cap going on right here, an eye bar. It's right here. It's all wool. It's similar to a Suffolk, but if you take a look at it, it has wool on its face, has wool on its legs. So sheep are a lot like isotopes because no matter how you slice it, sheep tend to have, at least most of them anyway, there are a few exceptions, but most of them have, a good majority of them have wool on them. So let's take a look at this analogy in terms of course, elements. There are three sheep, and as you can see, they all have different kinds of characteristics, but nobody can argue they're not sheep because they all are sheep because they have wool. Now we're going to take a look at three distinct types or kinds of elements, and we're going to look at nitrogen first. So let me erase that. These are nitrogen isotopes. The N means nitrogen. All three of these are nitrogen. All of them have a little bit different number on it, and we'll explain what that means in just a second. But 98% of the nitrogen that happens in our environment is nitrogen-14. Nitrogen-14 appears about 99 to 98% of the time. These other ones right here tend to happen the other 1 to 2% in different conditions or different circumstances. So what does this mean? Well, what it really means, let's get rid of that. Let's take a look at it a different way. This is called isotopic notation, and we'll have another video on that on itself. You can write an isotope, nitrogen-14 this way, or you can write it this way. If you write it this way, we probably ought to spend a little bit of time understanding what these notations mean. This right here is the atomic mass. That means that's the protons plus the neutrons together. That's what gives it its mass. This is the thing that defines a nitrogen. If we look at the atomic number, and that's what this is, it means the number of protons an element. So all nitrogen is going to have 7 protons. And every, let's say, carbon atom, because it is an atomic number of 6, is always going to have 6 protons. And you may wonder where I'm getting this. If we look at the periodic table, nitrogen is always going to have, this is the atomic number, that atomic number 7. So all 3 of these isotopes are all going to have 7 protons. That's just the way it's going to be. The basic characteristic, the thing that defines, the major thing that defines any kind of element is the number of protons it has, its atomic number. Same with sheep. The thing that defines sheep is, of course, wool. So even in the chemical realm, that's what those numbers mean. So let's try that again. This right here is atomic mass. This is the atomic number. So let's take a look at how many, we can figure out the number of protons, neutrons, and electrons. Because isotopes, when we look at any kind of nuclear chemistry, we're really talking about the nucleus within that atom. And that's where we're getting to the behavior and the characteristics from. So that's what we're looking at when we say nuclear chemistry. So the number of protons should be fairly easy to figure out. It's always the atomic number. So that's 7. So we're going to put 7 here. And then, of course, neutrons, the mass is neutrons plus the protons. We know what the protons are. So we take the atomic mass, which is 14, subtract out the protons, so we know what the the neutrons are going to be. So there are 7 neutrons in this. And then because it doesn't have a charge on it, we're just assuming then that is no charge on it, so it's going to be 7 because we're going to have to balance out the protons right here. So 7 protons, 7 neutrons, and 7 electrons in this one. Now let's go down to nitrogen 13. It has a different amount of neutrons, obviously, but notice again, it has 7 protons, which that's the thing that makes it nitrogen. So we're going to look at the number of protons, neutrons, and electrons. So the number of protons we should know is 7. Number of neutrons is the mass, atomic mass, minus the protons, and that would give us 6. So it has 1 fewer neutron than nitrogen 14. And of course, there's no charge plus or minus, so we assume it's at 0. So that also would be 7 electrons. So as you can see, it's fairly simple to figure out. It's really not a huge mystery. And you know, the other thing too is there are other isotopes besides nitrogen or besides carbon, besides oxygen. I'll show you those in a minute. But let's solve this last one. And again, nitrogen 15, we have the atomic number of 7. So I'm going to put the protons, 7 protons. And of course the neutrons are 15, which is the mass, minus the number of protons. That'll give us 8 neutrons. And then of course there's no charge. And of course to balance that out, we need 7 electrons. So it's 7, 8, and 7. So as you can see, this is relatively easy to figure out. I'll have some more difficult problems for you when we actually talk about a notation. It's kind of a handy skill to have when you're trying to understand and figure out what's going on in the nucleus of each of these isotopes. So let's move on to the next slide. And as I was stating earlier, that there are all different kinds of isotopes on this planet. 98% of the time, there's what you see in the periodic table, but you also have some variations of it along the way. For instance, again, right in the center, we're talking about, of course, nitrogen. And there's nitrogen 14, there's nitrogen 13, 15, 16, and 17. And then if we look at oxygen, there's oxygen 14, and 15, and 16, and all of these. These in the kind of the darker orange here, they're all stable. The ones in the lighter orange are not. And they're used and they're seen a little bit in a different light. So anyway, I just wanted to show you that isotopes really are naturally occurring. They tend to be of a little bit different in terms of the neutrons, but the protons are always the same. So again, if you're looking for a definition for isotopes, It's basically a variation of a particular element. Proteins are going to, the protons are always going to be staying the same, and you can find that out by looking at the periodic table. Look at the atomic number. That's the number of protons that are in that particular element. Like today, when we looked at nitrogen, 7 is the atomic number, and those are the number of protons. Irregardless of the isotope, it's always going to have 7 protons. So I hope that was helpful, and we'll be seeing you soon. And don't forget to watch part 2 of this video that has to do with notation. Thanks.